In this lecture, we will try to implement full subtractor using 1:8 demultiplexer. First, we will find out difference and borrow output. Then we will move to implementation using 1:8 demux. This is the truth table for full subtractor. Truth table for full subtractor, and we have to find out difference and borrow output. A, B are two numbers, and we want A minus B. Borrow input is there, so we have to find A minus B minus BI, and if this is equal to 1, this implies difference is equal to 1, and if borrow is involved in this subtraction, then B output is also equal to 1. Let's try to find out difference and borrow output for case 1. A is 0, B is 0, so we have 0 minus 0, this is equal to 0, and again BI is 0, so 0 minus 0 is equal to 0. So difference is going to be 0, and as there is no borrow involved, borrow output is also equal to 0. For case number 2, 0 minus 0 is 0, and 0 minus 1 we have to take borrow. 0 minus 1, 0 minus 1 we have to take borrow, and borrow is 2, so now we have 2 minus 1, so 1 is there, difference is 1, and as there is borrow involved, B output is also 1. In the same way, you have to complete the table. I'm just going to write down the values for difference and borrow output quickly. 1 0 1 0 0 1, and for borrow output we have 1 1 0 0 0 1. This is how the table will look once you find out the value for difference and borrow output. Now we can easily find out the standard SOP form. The SOP form is standard because we are writing it directly from truth table, and if I write down the min terms, and this is M0, M1, M2, M3, M4, M5, M6 and M7. For difference, the variables are A, B, BI, summation small m. Difference is high for M1, for M2, for M4 and for M7. So we will have 1, 2, 4, 7. And for borrow output, it is high for M1, M2, M3 and M7. So summation small m 1, 2, 3, 7. So this is what we have from the table, and now we can easily implement this by using 1:8 demultiplexer. I have already made the table for 1:8 demux. We have 3 selector variables and 8 outputs. Let's make 1:8 demux. One to 8 demux. We have 3 selector variables, S0, S1, S2, and we have 8 outputs. This is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. So these are the 8 outputs, and we have single input in demux, and in this case let's say input is always high, 1, right? Now we will consider the first case and try to find out Y0, Y1, Y2, Y3 all the way to Y7. When all the 3 selector variables are 0, the input will be linked to Y0. So Y0 is 1, and Y1 is 0, Y2 is 0, Y3 is 0, Y4 is 0, Y5 is 0, Y6 and Y7 are 0. In the same way, we have to complete the table. I will complete it quickly. This is the complete table for 1:8 demux, and now the important part comes. We have to implement the full adder. We have already obtained the standard SOP form for difference and borrow output First we will try to implement the difference. The variables are a, b, bi. I will replace s0 with bi, borrow input, s1 with b, and s2 with a. When a, b, bi all three are 0, the difference is 0. So we don't have to do anything. We will keep y0 floating. When a is 0, b is 0, and bi is 1, in that case difference is 1, and we need that. So I will use one OR gate, and the output of this OR gate is difference. And when a, b are 0, bi is 1, you can see y1 is high and we need this. So I will feed y1 to this OR gate. And when a is 0, b is 1, and bi is 0, in that case also you can see difference is high. So we are going to require y2 as well for difference. So I will feed y2 to this OR gate. For the third case, when a is 0, b is 1, and bi is 0, the difference is 0. So we will keep y3 floating. We are not going to give it to this OR gate. When a is 0, b is 1, and bi is 1, in this case we have difference as 1. So we will have y4 as one of the input to this OR gate. And finally, when a is 1, b is 1, and bi is 1, the difference is 1. So y7 will act as the last input to this OR gate. In the same way, we can implement the borrow output. I will use another OR gate. Right now I am trying to obtain the circuit by using this truth table, but you can directly use the minterms that we have obtained. I will try to implement borrow output from this minterm only. 1, 2, 3, 7 are the minterms in case of borrow output. So we will have y1 as one of the input, y2 as the other input, y3 as the next input, and finally y7 will act as the last input. So this is how we have to implement a borrow output, and this circuit will work as full subtractor. So this is all that you have to do in order to obtain full subtractor by using 1:8 demultiplexer. A very simple topic and very important at the same time. In the same way, you can implement full adder that you can do by yourself. So this is all for this presentation. See you in the next one.